everyone, I'm sitting here in a playground today. I'm not doing very much playing, but the reason I'm here is because I wanted to take a look at what we can find in a playground. And I don't mean all the cool play structures, what I mean is the dirt on the ground. Now in this case, as you can hear, right, this playground is full of gravel. Some playgrounds are full of gravel, others are filled with sand, and this is for a number of reasons, but one thing you'll notice is that when you're in a playgrounds typically don't have a lot of plants growing inside of them. The reason for that is because, well, we know plants don't really like gravel to grow in. Plants don't like sand to grow in by itself. But why is that? What kind of soils do plants actually like to grow in? What makes a soil good for plants? Let's take a look. Now when it comes to soil, there are two ways that we can kind of break it down. The first way that we can look at soil is by the actual particles that make up the soil itself. Or we can also look at the pores in between those particles. Those pores, those are the spaces in between. And that's really important because that tells us how much water can actually be in the soil, as well as whether air can be circulating through it. And we want air to circulate through the soil so that microorganisms in the soil can grab onto the nitrogen and make it into a form that plants and other organisms can use. But first, let's look at the particles. If you remember back when we talked about erosion, we talked about how weathering could cause bits and pieces of rock, really small bits, to come off, and we called that sediment. And those little bits and pieces of rock are what eventually make up what we call the mineral particles of soil. And so when we look at soil, the actual little bits and pieces of rock, those are the mineral particles. But there's another kind of particles that we can refer to in soil as well. And those are the little bits and pieces of once living plants and animals that are starting to decompose. These are really small pieces that we call organic particles, or humus. Not hummus that you would eat, but humus. Now obviously those organic particles are going to be really important for plants to be able to access a lot of nutrients that they need as well. Now we can classify different types of soil based on the size of the mineral particles. So if we see mineral particles that are about 2 millimeters in diameter, all the way to about as small as 0.1 millimeters in diameter. This is our largest size of mineral particles, typically, and this is what we usually refer to as sand. Now, you can get really, really small. The smallest particles, which are 0.0002 millimeters, or even smaller in diameter, and that's the type of soil that we call clay. Now, if it's somewhere in between there, from 0.0002 millimeters to 0.1 millimeters, that's what we call silt. That's kind of our in-between. So we have these three types of soil. We have sand, silt, and clay. But it's not very often that you're going to come across a sample of soil that is only one of these types. Usually we're going to find combinations of all three. Now, how do we know which combination of those three types of soils is best for plants? Well, that still depends. Now, you and I know if we're going to be walking down a beach, it's not very often that you're going to find plants growing in exclusively sand. Just like if we came across a sample that was exclusively clay, we're not going to see plants growing there necessarily either. Usually what we're going to find is that plants prefer to grow in a combination of our three main soil types. Now, this is going to be different for every kind of plant. For example, plants that grow in the desert, they're going to be adapted to be able to grow in soils that have a higher amount of sand than plants, say, in the tropics or even here in Canada. However, most plants are going to be able to grow in samples of soil that have about equal combinations of each type of soil. And the reason for this is because it allows for the spaces between those mineral particles. They're not going to be so big like they are in between the particles of sand that water is just going to rush through. They're not going to be so small that it's going to all just be totally inundated with water and not allow air to come in and circulate like it would in clay. If we have a combination of all three, we have a great opportunity to be able to hold on to water, but still allow air to circulate, and still be able to anchor the plant in at the roots. Now, like we said, we still need another important part in our soil, and that's those organic particles, or the humus. And that's where the plant is going to be getting its nutrients. So once we have that perfect combination of our three soil types, as well as a good amount of organic particles, we now have what we would refer to as loam, or loam soil. And this is what's typically ideal for plants to be growing in. But how do we test different soils to actually see how much of each type of soil is in it? Now, one way that scientists can get an idea of what's in the soil is by a really simple, what we would call field test. And the reason we call it a field test is because the scientists could do this just out in the field. They don't need to be in a laboratory. And so this is something that you can actually even try at home. All you need is a bit of soil that you're gonna test. So I have here a bit of soil, and the first thing you gotta do is just reach down and grab a handful. Now you pull out this handful of soil, make sure you've got a pretty good handful, but take out any of the bits that are, if you have any bits of organic matter inside, any rocks, that's gonna kind of ruin things. So make sure you just have just soil, just dirt, and you can break it down into pieces that aren't any bigger than a couple millimeters across. Now once you've done that, you're going to take just a little bit of water and add it to this dirt to make it nice and muddy. Now, don't add too much water, otherwise obviously it's just going to be a whole bunch of runny mud and you're not going to be able to do anything with this. What we're trying to do is we're trying to put enough water into the soil that you can it starts to get soft and it all starts to stick together. Play around with it, and you're going to kind of break it open a little bit, squish it back together, make sure it's all broken up really nicely. We're just going to sit here and squish this mud for a little bit. Now, as you're squishing it, I want you to think about some of the texture that you feel. Depending on the soil that you're holding, you might feel some different textures. Now, if there's a lot of sand in your sample of soil, then you'll probably be able to actually feel those grains of sand, and it'll feel, a little bit, grainy. However, if there's a lot of clay in your sample, you'll feel that in how silky and kind of smooth or even sticky that it might feel. All right, now once you've squished it for about, a couple minutes, now we can do what's called a ribbon test. And what a ribbon test is you're gonna take your squished up mud and you're gonna squish it through your thumb and your forefinger like this. You're gonna keep squishing it through, and you're gonna create what's called a ribbon. And what we're gonna do is we're gonna see how big these ribbons can get. Now, the length of these ribbons can be an indicator in some of the things that are gonna be found in the soil. Now, what you can see here is in the ribbons that I've made from the sample I had, all of my ribbons are about 1 centimeter to 2 centimeters long. So it's stuck together enough to make it so it was a couple centimeters long, but not so much that it's going to be longer than that, 3, 4, 5 centimeters. Now, if your ribbons are about 1 to 2 to 2.5 centimeters long, that's a pretty good indicator that there's a really good balance of all 3 types of soil in your sample. This is what we would call loamy soil. If your ribbon was able to get really long, upwards of 5, 6 centimeters long, well, that just means it's sticking together better. And what do we know of our 3 types of soil? Which one sticks best? Well, that would be clay. So that tells us that your sample has a lot more clay in it. However, on the other hand, if you can't even make ribbons that are 1 centimeter long, then that tells you that you're probably dealing with, very sandy soil. Now, it makes sense that my sample is mostly loamy soil because I took it from a garden, which is a place where that soil is worked on and is taken care of so that it can actually grow plants. And we know that loamy soil is the best kind of soil to grow most plants. Now, another way that we can test for soil composition, or the different amounts of each type of soil in a sample, is by looking at how they separate into layers based on their particle size. Now, you can even try this at home. All you need is a mason jar or other container, similar to these 2 I have in front of me, as long as it has a lid. Once you have that container, you can go out and take a soil sample from wherever. Alright, I've got my soil sample here. Let's head back to the classroom. Now, once you have your sample, you're going to start to fill it with water. Now, you can fill it just about right to the very top, as long as you have a little bit of space, because you're going to want to shake it afterwards. Now, once you have your sample, you've put your lid on, it's full of water. Now it's time to shake it. So you want to shake it for, a good 30 seconds to a minute to make sure that all of the soil mineral particles have been separated and are suspended in the water. Now once you finish shaking, you'll notice it's all super cloudy. Now obviously my lid doesn't fit on perfectly, so I made a bit of a mess. But as you'll notice, it's really muddy, really murky, it's hard to see anything in here. Now over time, what's gonna happen is the mineral particles are gonna start to separate, they're gonna start to sink to the bottom. Now the mineral particles that are the largest, they're gonna sink to the bottom first, and then the next smallest level, and then the next smallest level. So on the bottom, we should end up with any sand that was in our sample. Our silt should be the next layer, and then finally the clay. You'll notice that if you have sand in your sample, it will actually settle first, and it'll settle after only a couple minutes. After about half an hour, you'll notice that the silt will start to settle, but it'll take about 24 hours for any clay in your sample to settle and make a layer. Now this is after about 24 hours of each type of soil sitting. So first we'll look at this sample that I took from the cattle pasture, and if you look really closely, you can see that we have some different layers. Now, near the top here, we have these really fine particles, and this is the clay. The clay is what settles last because the particles are the smallest. Most of the rest of this is silt. Here we've got some more gravel on the bottom, and this is kind of more gravel or sandy parts. And so obviously we have the larger particles here, our silt in the middle and clay on top. Now this sample is one that I took from a farmer's field. Now this is a little bit different than what you'd find in a cattle pasture, because a cattle pasture, we just allow the grass to grow and regrow each year, whereas in a farmer's field, where the farmer is putting in a lot more nutrients, he's working the soil much more intentionally. Now as you'll notice, not only is it darker, but there is much less clay on top, and it's mostly silt. There isn't hardly any sand in here. We don't want too much sand because otherwise it won't be able to hold water very well. Now that's everything we're going to talk about today in terms of soil composition, so we'll see you next time.